హాయ్ స్టూడెంట్స్, వెల్కమ్ టు గోవిద్య. ఈరోజు మనం ALP CBT-02 సంబంధించి ఎలక్ట్రీషియన్ ట్రేడ్ మాక్ టెస్ట్ 4 సొల్యూషన్స్ డిస్కస్ చేద్దాం. ఓకే, ఫస్ట్ క్వశ్చన్, ఇన్ SI సిస్టమ్ ద బేసిక్ యూనిట్ ఎలక్ట్రిక్ ఛార్జ్. ఓకే, ద బేసిక్ యూనిట్ ఆఫ్ ఎలక్ట్రిక్ ఛార్జ్. ఓకే, ఛార్జ్ యొక్క యూనిట్స్ ఏంటి? ఛార్జ్ ఈజ్ ఈక్వల్ టు Q ఈజ్ ఈక్వల్ టు CV. ఓకే, ఛార్జ్ యొక్క యూనిట్స్ వచ్చేసి కూలుంబ్స్. Okay, from the options, option C is the correct answer. Okay, option A, volt is the unit of voltage. Voltage units are volts. Alage Celsius is the unit of temperature. Alage ampere is the unit of current. Okay, next question, 4 resistors of 8 ohm are connected in parallel. Okay, 4 resistors each is having 8 ohm are connected in parallel. Find the net resistance in the circuit. Okay, 4 resistors each is having 8 ohms are connected in parallel. Okay, we have to find net resistance. Okay, 1 by R net is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Okay, now 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8, we will get 4 by 8. 4 by 8 is equal to 1 by 2. Okay, 1 by R net is equal to 1 by 2. Okay, R net is equal to 2 ohms. Okay, R net is equal to 2 ohms. From the options, option C is the correct answer. Okay, next question, the reciprocal of frequency is, okay, the reciprocal of frequency. The reciprocal of frequency means 1 by frequency. 1 by frequency is equal to time period. Okay, from the options, option A is the correct answer. Alage reciprocal of time period. Reciprocal of time period is equal to frequency. Okay, next question, 1 milliohm is equal to, okay, 1 milliohm is equal to, okay, 1 milliohm is equal to 10 power minus 3 ohms. Okay, we can also write 1 by 10 power 3 ohms. Okay, we can also write 1 by 1000 ohms. Okay, from the options, option C is the correct answer. Okay, next question, the unit of electrical power is, okay, unit of electrical power. Okay, we have energy formula. Energy is equal to power into time. Energy is equal to power into time. Okay, from this equation we can write power is equal to energy by time. Okay, the unit of energy is joules. Alage unit of time is second. Okay, the unit of power is joule per second. From the options, option B is the correct answer. Okay, next question, the resistance of 100 watt 200 volts lamp is, okay, power is given and voltage is given, we have to find resistance. Okay, we have power formula. Power P is equal to V square by R. From here we will get R is equal to V square by P. Okay, V is given, V is 200 volts, 200 into 200, 200 into 200 by power is 100. Okay, 100 1 ja, 100 2 ja, this is 200, 200 into 2 400, 400 ohms is the resistance value. From the options, option C is the correct answer. Okay, next question, the amount of current flowing through a resistance depends on, okay, the amount of current flowing through a resistance depends on only on applied voltage, the ohmic value of the resistance, on voltage and ohmic value of the resistance, and none of the above. Okay, we have Ohm's law. Ohm's law is V is equal to IR. Okay, from here we will write I is equal to V by R. Okay, the current will depends on voltage and resistance. Current is directly proportional to voltage, applied voltage, and current is inversely proportional to resistance. Okay, the current will depend on applied voltage and also resistance. Okay, from the options, option C is the correct answer. Okay, depends on applied voltage and ohmic value of the resistance. Okay, next question. A 110 watt electrical bulb is connected across 220 volt voltage source. Then what will be the resistance of bulb? Okay, power rating is 110 watts and voltage rating is 220 volts. We have to find resistance of the bulb. Okay, we have power formula. P is equal to V square by R. Okay, power is given and voltage is also given. We have to find resistance. R is equal to V square by P. Okay, V value is given. V is 220 volts. 220 into 220. Okay, power is 110. Okay, 110 1 ja, 110 2 ja, 2 into 220 is equal to 440 ohms. Okay, from the options, option C is the correct answer. Okay, next question. 3 resistors 2 ohm, 3 ohm and 6 ohm are connected in parallel. Okay, what will be the total resistance of the combination circuit? Okay, 2 ohm, 3 ohm and 6 ohm are connected in parallel. Okay, I will draw the circuit. This is 2 ohm resistor and this is 3 ohm resistor and this is 6 ohm resistors. These 3 are connected in parallel. Okay, now we have to find effective resistance or effective. Okay, now 1 by R effective is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, R1 is 2 ohms plus R2 is 3 ohms plus R3 is 6 ohms. LCM is 6. Okay, we will get 3 plus 2 plus 1. 6 by 6 is equal to 1 ohm. Okay, R 1 by R effective is equal to 1 6 1 ja 6. Okay, 1 by 1 ohm. Now we will get R effective is equal to 1 ohm. Okay, from the options, option A is the correct answer. Okay, next question. Ohm's law states that, okay, Ohm's law, okay, Ohm's law ante manaki V is equal to IR, voltage is directly proportional to current. Ohm's law. V is directly proportional to I. We can also write V is equal to IR. Okay, from here we will write I is equal to V by R. Okay, we can also write R is equal to V by I. Okay, from the options, option D is the correct answer. I is equal to V by R. I is equal to V by R. Okay, next question. What is the frequency of AC power line voltage in India? Okay, Indian frequency is 50 hertz. Indian frequency is 50 hertz. Okay, from the options, option A is the correct answer. Okay, next question. A single phase conductor is made from group of wires is called. Okay, a single conductor made from group of conductors is called. Okay, this is single conductor. Okay, we call solid conductor. Okay, single conductor ni manam solid conductor nu antamu. Okay, solid conductor. Okay, alage single conductor can be made up of group of conductors. Okay, this is stranded conductor. Okay, stranded conductor endukante corona loss skin effect ni reduce cheyanika. Okay, to reduce skin effect. Okay, okay, from the options, option B is the correct answer. Okay, next question. In a suspension type insulator, the discs are connected in parallel, series, either parallel or series, none of the above. Okay, suspension type, the insulators, the discs are connected in series. Okay, this is disc. Okay, these discs are connected in series. Okay, this is conductor. Okay, each disc can withstand voltage up to 11 kV. 11 kV. Okay, depending on voltage, we will increase the number of discs. Okay, from the options, option B is the correct answer. Discs are connected in series. Okay, this is conductor. Okay, next question. A 144 ampere hour battery can provide 8 amperes current for approximately how many hours? Okay, battery capacity is equal to current into discharge time. Okay, battery capacity is given and current is given. We have to find discharge time. Okay, battery capacity is 144 ampere hour. Current rating is 8. Okay, we have to find discharge time T. T is equal to 144 by 8. 8 1 ja 8. Okay, 6 remains 64. 8 8 ja 64. T is equal to 18 hours. 18 hours. From the options, option D is the correct answer. Okay, next question. The electrical energy is expressed in, okay, electrical energy is expressed in voltage square into current square, voltage into current into power factor, or power into time, or current square into resistance. Okay, energy is equal to power into time. Energy is equal to power into time. Okay, from the options, option C is the correct answer. Okay, next question. The number of cells required to get 24 volts terminal voltage by using lead acid battery. Okay, మనకు lead acid batteries ని number of lead acid batteries ని యూజ్ చేసి మన terminal voltage 24 volts రావాలంటే how many cells we have to use? Okay, the average EMF of lead acid battery is equal to 2 volts. Okay, the average voltage of lead acid battery is 2 volts. Okay, now we have to use these lead acid batteries to get 24 volts. Okay, we have one formula, N into E is equal to 24 volts. Okay, N, how many number we have to find? N, number of cells. N, each cell is having 2 volts. Okay, is equal to 24. 2 1 ja 2, 12 ja 12 ja. N is equal to 12. 12 cells we have to use to get 24 volts. Okay, from the options, option C is the correct answer. Okay, next question. What is the output voltage of if 5 cells of 1.5 volts are connected in parallel? Okay, 5 cells each is having 1.5 volts are connected in parallel. Okay, the resultant output voltage is, okay, 1.5 volt. This is 1.5 volt battery. Like this, 5 batteries are connected in parallel. 5 batteries are connected in parallel. Okay, మనకు parallel లో voltage వచ్చేసి సేమ్ ఉంటుంది 1.5 volts. 1.5 volts. Okay, the output voltage మనకు parallel లో మనకు voltage అనేది remains constant. అవుట్పుట్ voltage వచ్చేసి కూడా V అవుట్పుట్ వచ్చేసి కూడా మనకి 1.5 volts మాత్రమే ఉంటుంది. అదే సిరీస్లో అయితే మనకు voltage అనేది యాడ్ అవుతుంది. ఓకే, ఫ్రమ్ ద ఆప్షన్స్, ఆప్షన్ B is the correct answer. Okay, next question. The storage of battery in a car has EMF of 12 volts if the internal resistance of the battery is 0.5 ohms. What is the maximum current that can drawn from the battery? Okay, we have to find maximum current. Okay, I maximum current is equal to V by R. Okay, V, what is the value of V? V is 12 volts. Okay, అలాగే internal resistance of the battery is 0.4 ohms. Okay, 4 1 ja 4 30 ja. Okay, current is, maximum current is 30 amperes. Okay, from the options, option D is the correct answer. Okay, next question. The most common fault in electrical system, okay, 3-phase fault or single line to ground fault, single line to earth or single line to ground, both are same. Okay, alage double line to ground fault or double line fault. Okay, most common fault is LG fault. Okay, the next most common fault is LL fault. Okay, ఆ తర్వాత LG fault. Okay, ఆ తర్వాత triple L fault. Okay, ఆ తర్వాత triple L G fault. Okay, the most common fault is line to ground fault or line to earth fault. Okay, option B is the correct answer. Okay, next question. Which of the following short circuit is most dangerous? Okay, most dangerous fault. Okay, most dangerous fault వచ్చేసి triple L fault. Okay, triple L fault. Okay, we can also call dead short circuit. Okay, dead short circuit. Okay, from the options, option B is the correct answer. Okay, next question. The distance between two adjacent poles is, okay, sag or span length or HSL or guarding. Okay, distance between two adjacent poles. Okay, this is one pole, and this is one more pole. Okay, this is a conductor. Okay, the distance between two poles. Okay, this is the distance between two poles. Okay, distance between two poles is called span or span length. Okay, and distance between highest point of the conductor and this lowest point of the conductor. Okay, this distance is called sag. Okay, the distance between two poles is called span length, and the distance between highest point of the conductor and lowest point of the conductor is called sag. Okay, now distance between two adjacent poles is span length. Option B is the correct answer. Okay, next question. In the power measurement by 2-watt meter method, okay, power measurement by 2-watt meter method, the reading of 1 watt meter will be 0. Okay, the in 2-watt meter method, 2-watt meters la manaki oka watt meter reading vachesi 0. Then power factor of the load is, okay, we have power factor formula. Okay, cos pi, power factor is equal to cos pi. Power factor is equal to cos pi is equal to cos of tan inverse root 3 W1 minus W2 by W1 plus W2. Okay, now W1 is equal to complete reading. Okay, W2 is equal to 0. Okay, substitute here, W2 is equal to 0. Okay, cos of tan inverse root 3 W1 is equal to W by W. Okay, W will cancel. Tan inverse of root 3 is equal to 60. Okay, cos 60 is equal to 0.5. Okay, 0.5 lagging power factor. Okay, from the options, option A is the correct answer. Okay, next question. What is the power factor in case of 2-watt meter method for measuring 3-phase power if watt meter reading is equal and opposite? Okay, equal and opposite ante manaki W1 is equal to W ainappudu W2 is equal to minus W. Okay, this is the condition. Okay, at this condition, what is the power factor? Okay, we have power factor formula, cos pi is equal to cos of tan inverse root 3 W1 minus W2 by W1 plus W2. Okay, these values substitute here. Okay, cos of tan inverse root 3 W minus of minus W is equal to 2 plus W by W minus W. Okay, W1 is W and W2 is minus W. Okay, W1 minus W minus W is equal to 0. 1 by 0 is equal to infinity. Tan inverse infinity. Cos of tan inverse infinity. Tan inverse infinity is equal to 90 degrees. Okay, cos 90. Okay, cos 90 is equal to 0. Okay, power factor is 0. Okay, at this condition power factor is 0. Okay, from the options, option B is the correct answer. Okay, next question. The resistance of ideal voltmeter is, okay, ideal voltmeter. Okay, we have 2 meters. Okay, voltmeter and ammeters. Voltmeter is connected in parallel with load, okay. Ammeter is connected in series with load, okay. Voltmeter and ammeter, voltmeter and ammeter, okay. Voltmeter is connected in parallel, okay. Internal resistance is, voltmeter internal resistance is infinite, ideally infinite, very high, practically very high, okay. Next, ammeter is connected in series, okay. Internal resistance is zero, ideally, okay. Alage very small for practical meters, okay. Here in the question they are asking ideal voltmeter ki manaki infinite resistance anedi untundi, okay. From the options, option B is the correct answer, okay. Next question, the resistance can be measured by voltmeter, wattmeter, ohmmeter or ammeter, okay. Resistance can be measured by ohmmeter, okay. Option C is the correct answer. Alage voltmeter, by using voltmeter we can measure voltage, okay. Alage wattmeter, by using wattmeter we can measure power, okay. Alage ammeter, by using ammeter we can measure current, by using ammeter we can measure current, by using wattmeter we can measure power, by using voltmeter we can measure voltage. Alage by using ohmmeter we can measure resistance, okay.